Do you know that mathematicians study braids? In particular, they study something called braid groups, and braid groups have applications, of course, in things like knot theory, but surprisingly, they also have interesting applications in mathematical physics. Braid groups were actually introduced by Emil Artin, and Artin was my academic great-grandfather, so he was the PhD advisor of my PhD advisor's advisor. These are examples of elements in the braid group in two strands. This is the identity braid. In this braid, the two strands are interchanged, but in this one, the first braid goes over and the other one goes under. In this one, they are also exchanged, but this one goes under and this one goes over. And you can see that these two elements are inverses of each other, because if you compose them, which is you connect them, then this one goes over and over back to where it started, so there's no braiding happening once they are connected. However, this element is different from those, because in here there is some braiding happening. This one is in fact what happens when you compose this one with itself. And in fact, you can prove that B2, the braid group in two elements, is generated by this element. This is the identity, this is the generator, this is the inverse of the generator, this is twice that one, or the square of that element, and so on. So you can prove that in fact B2 is isomorphic to the infinite group in one generator, the cyclic infinite group in one generator, so B2 is isomorphic to just the integers. However, B3 is more complicated, and it's not isomorphic to an abelian group. It's in fact an example of a non-abelian infinite group.